With the distributed property, we're going to take it a step further than maybe what you've seen in the past. You've looked at distributed property in years past, but we're going to see some other applications to that. So our learning target is that you can use the distributed property to simplify expressions. So this is what you've seen before. You have a set of parentheses and you have something outside the parentheses, such as that A right there. It's something on the outside, or this 5 here, and it's being multiplied by what's inside the parentheses, either something being added in the parentheses or something being subtracted in the parentheses. And you know what to do is you take what's outside the parentheses and you multiply it by each term inside the parentheses. So the A is multiplied by the B and the C. It's adding in the middle because it was adding in the middle here. And you come down here to a subtraction example. We'll do the number example here. It ends up being 7 times 9, like there, and 7 times 6. It's subtracting in the middle because inside the parentheses was subtraction, and where possible you go ahead and simplify that some more, so that would end up being 63 minus 42 and simplifying from there. Here is another way to think about the distributed property. We're going to use Angry Birds as the example. You know, to be successful, I have to use one bird to kill a couple of hogs, kind of like 2 birds with 1 stone. So if I'm going to shoot this bird over, he's going to hit this hog and this hog over here, this pig, whatever you want to call it. So you can see where this is actually used. It's bird times the pig plus bird times the no helmet pig. If you'll look below, using the distributive property, this is more like what you're going to see actually this year in algebra. You have a number or some other term on the outside, and it's multiplied by each term on the inside. So it's 5 times m plus 5 times 12. That's equivalent to if you put multiplication signs in the middle. I try to, you know, kind of push you away from that in algebra because that way we don't confuse it with the variable x. But simplified down, it's 5m plus 60 because 5 times 12 is 60. So rewriting fraction expressions, here's where it's something new for you. You have something like this, 7x plus 2 over 5. And actually, let's put a screen shade up here so you're not overwhelmed. There we go. Okay, so what I can do, this is like splitting up all this division here. We know that multiplying by the reciprocal of 5, 1/5, is the same thing as dividing by 5. So this whole quantity on top, 7x plus 2, is being divided by 5. So I'm writing division as multiplication. This is a step that you're going to end up doing more in your head, and you're becoming more down to this right here. And you are distributing dividing by 5. So I'm going to have 7x times 1/5, same thing as dividing by 5, plus 1/5 times 2. I'm distributing that 1/5. And then you simplify it down, and you have 7x over 5 plus 2 over 5. The more fluent you get with this, you'll be able to go directly from the beginning problem, 7x plus 2 over 5, to 7x over 5 plus 2 over 5. So you're distributing that division just like before you were distributing the multiplication. Another way you'll see this is the multiplication property of -1, where you have a negative sign in front of the parentheses. There's not a 1 listed there, but we know that that means the same thing as -1 times that. So in blue, read with me, a negative outside the parentheses means to multiply each term by -1. Basically, it changes each term to its opposite. -1 times a is -a. -1 times +5 is -5. You can see that down here where it's all kinds of subtractions and negatives. It changes it to its opposite. -x becomes +x. -12 becomes +12. And we want to make sure that we understand the different parts of the expression. When I say term, I'm meaning a number, a variable, or a product of a number and a variable where they're kind of sandwiched together, separated by a plus or a subtraction sign in an expression. So if you look over here, 3x is a term, 5 is a term, and 20 is a term. I have 3 terms in that equation. The equation is the whole thing. The expression is each side of the equal sign. Next word is a constant, a term without a variable. 5. It's just 5. Its value is always the same. So that's why it's constant. And then you have coefficient. This is the number multiplied by the variable. It tells how many times the variable is being added. 3 is the coefficient. That means I have 3 x's plus 5. I could expand that expression there out and have x plus x plus x plus 5. But I can shrink it down by saying 3x plus 5. Combining like terms is something you did last year. So this should be somewhat familiar to you. Like terms are the ones that have the same variable to the same power. And to combine like terms, you basically add the coefficients. So let's take these one at a time. Let's go with the red one first. 3y minus y. Those are like terms. They have the same variable. They're both to the first power. So combine their coefficients. 3, and that's like subtracting 1, or 3 and negative 1, which becomes 2y. For the green ones, negative 7m to the fourth and minus 5m to the fourth. M to the fourth, they have the same variables to the same power, so combine those coefficients. Negative 7 and negative 5 combine to be negative 12. Now with the orange here, 7y to the third z minus 6y z to the third plus y to the third z. All three of those are not like terms. Only the first one and the last one are like terms because it's y to the third z, y to the third z. So combine those. 7 and 1, it's like the invisible coefficient, gives you 8 y to the third z, and then the minus 6, 7 z to the third stays there. We'll get a lot more practice of this in class.
Okay, with simplifying expressions, part of that is taking the parentheses out of there. And when you see that number right up against the parentheses, remember, it's like an automatic reaction. I need to distribute what is outside the parentheses. So in this case, we're taking 1/4 and we're going to multiply it times 4f and also times negative 8. In your head, multiply 1/4 times 4. That becomes 4 over 4, which is 1. 1f is simply f. It's a positive times a negative for the second multiplication. So it's going to be negative, and 1/4 times 8, that would be like 8 over 4, which is 2. So simplified, that is f over 2. Looking at practice B, it's negative, then what's in parentheses, negative m plus n minus 1. So what is happening is you're distributing that negative to each term. There are 3 terms in this case, and when you're multiplying by a negative, this is the multiplication property of negative 1. What is happening is you're changing each term to its opposite sign. That's like multiplying negative 1 times each of those. So this becomes positive m, n becomes negative n, and negative 1 becomes positive 1. So simplify, that is m minus n plus 1. I cannot combine any of those because none of those are like terms. Looking down at C and D, I can combine some like terms here. That should be a squared right there. That got rubbed off a little bit. Add that square for you. Okay. So C's expression is negative 7h plus 3h squared minus 4h minus 3. That 4 also got rubbed off a little bit. That might be worse. Okay, let's start about combining some like terms here. Starting with negative 7h. I look through there and I'm looking for something with the same variable to the same power. 3h squared is not like terms because this one is squared and this is to the first power. However, negative 4h is like negative same h because they both have h to the first power. Notice when I box this, I included the negative sign in front of there. It is with it because the coefficient is not 4 but negative 4. Now I'm going to combine those like terms, and when I combine those like terms, I am combining their coefficients. Negative 7 and negative 4 combine to make negative 11. So I have negative 11h. 3h squared and negative 3 are not like terms, so they come down. And to actually put it in proper standard form, 3h squared comes out in front because you start with the greatest power. No, it's not plus 3. It is minus 3. Now, if you had wrote it as negative 11h plus 3h squared minus 3, I would accept that because those are equivalent expressions. It's just important that you keep the negative sign with the 11. Now, let's come over here to D. 8 minus 9x over 3. What's happening is you're taking that top expression and you're dividing by 3, which, as we can see, dividing by 3 is the same thing as multiplying by a third. So how this applies to distributive property is this is the same thing as 1/3 times 8 minus 9x. So you can think of it like that, like you're distributing the 1/3, or think of it as dividing each term by 3. 8 divided by 3 is going to stay at 8 over 3. You don't have to worry about turning it into a mixed number because in algebra we keep it as an improper fraction because it's something we'll look at later in this class called slope. But I can go to negative 9x divided by 3. 9 divided by 3 is 3. So it is 8 over 3 minus 3x. And that is simplified.